I'm Carmelo. Today I will focus on comparing automotive secure gateway design approaches. We will go through the motivation. We will see why it's important to secure this component and what's the role of the secure gateway in the automotive system. So we will see also the design of the secure gateway, and we will talk about the separation kernel, so how to use separation kernel to design these systems. And we will also see the Linux, what's the role of the commodity operating system in the secure gateways, and how to protect this system. So then we will talk about how to protect sensitive data, and we will focus at the end on the I/O device security. So the automotive trend, the new automotive trend, is to bring in different electronic domains in single platform, as it is done for the cockpit. Also for the secure gateway, it's common to use different domain on the same system. So, and also the increasing of the intelligence of the vehicle is at the same time increasing the surface attack of the hacker. So that's why we need to protect those systems from the external attack. The vulnerability happen usually because the security is not built from the ground up. And also when the software is composed by a lot of line of codes, the probability to have security or a bug in general is very high. There are also some trade-offs. So using the costs, so the time to market, the feature that we would like to add. So we have to take care about introducing security without not increasing a lot the costs. And also the time to market is very important. So productivity of the developers is also very important in this case. Since the car is connected to the external world, as we mentioned before, we need to protect the car in some way. And we use this component named gateway that is connected to the internal other components like the cluster, the IVI, and so on, is connected to the car bus, but is also connected to the external network. So we have to protect the car using this component. As usual, when we talk about security, we also have a compromise between performance and reliability, right? So those three properties, security, performance, and reliability, are really strictly related. So when increasing security, we can lose performance. So we have to be sure that we are not losing security. Also, when increasing performance, we can lose reliability. So we have also to take care about this aspect. The most common principle in the cybersecurity are the authentication, the encryption, and the famous PKI, the device lifecycle management, so the generation of the keys when we are talking about an asymmetric protocols, security protocols. Then those three methods are not sufficient to protect the system, so are not enough. So we need also to protect the system from low-level side. And the low-level security, especially in the secure gateways, is really important. So a common application, common software architecture, and the best, in my opinion, to design the secure gateway is using a real-time operating system. We will see that this real-time operating system will be a micro separation kernel, and that has different application and different services running on top, but where those services are really separated between each other. So the best way to design a secure gateway is to use a separation kernel. And the separation is fundamental. So security and the safety architecture is really important, because we need, in this case, we need to add the separation between the components. So we have to identify what are the critical components with respect of the security, with respect of the safety, and which are not critical for the security and safety. In this case, once we identify the component, we can really separate the system. And we know what is the criticality between the criticality of these components. We also need to enforce the access control and restrict the access control of these components. So those components, they do not have to interfere with each other. Also, the separation has other benefits, so that actually not all the components need to be retested when we add a new component to the system. So if we would like to add a new feature, can be separated from the rest of the system, and we do not need probably to retest everything. We just need to do the test of that feature. So we don't need to rerun integration tests. So a secure and a safe RTOS, like Integrity for Greenhill software, allows us to separate application and to allow to run on the same system mixed criticality component. So component that have high security requirement or safety requirement, along with components that do not have those requirements. In this way, we can also isolate and protect sensitive data, and we can secure the bus from the interference from the outside. So, and secure and safe RTOS should be ultra reliable and deterministic, and should be designed from the day one to be safe, secure, and deterministic. Separation kernel architecture looks like the picture we are seeing. We have in blue, we have application, we have device drivers, and file systems. Those are running in user space. On top of an RTOS separation microkernel, which is actually managing the low-level part and is actually communicating with hardware directly. In a mixed criticality system where we have more than one application that, for example, is certified ASIL for the automotive, and we have different level of certification, along with application not certified, we will need this kernel pre-certified to guarantee the whole system safety and in general security. So from the SLD application, we are protected because the SLC and SLB cannot interfere with this kind of application. Also, the not certified application cannot interfere with the others. So if we would like to add a new feature, we can do that without impacting the certification, because the separation is guaranteed. We also need to consider that on the secure gateway, the commodity operating system have been used for a while. So we, especially Linux, is used in this gateway running natively. The advantage of Linux is that it provides an attractive set of ready-made software, but it consists in a lot line of code. So the probability to find a security bug is very high. But there is a powerful method for improving this kind of secure gateway that are using Linux. So is using actually a separation microkernel. We will see later that acts as hypervisor. This is the scenario. We have the Linux running natively on secure gateway. And you can see that the Linux is managing directly the crypto libraries. So the encryption keys are managed by Linux directly. And for a system that is a monolith kernel with a lot of line of code, this is not really good for the security point of view. Also, the Linux is managing directly the devices. Let's introduce the virtualization type. So we actually have two kinds of virtualization. The type 1, where the hypervisor is running bare metal on the SoC and is providing the virtualization. And we have the type 2, where the hypervisor is running on top of another operating system. So the example of the type 2 are VirtualBox and VMware. Now, let's talk about microkernel hosted hypervisor. So what the hypervisor needs to do needs to partition and protect memory resources, needs to secure the access control for the I/O device, needs to use inter-process communication between the native application, but also between native application and the guest, and needs to schedule the workload efficiently across the cores in case of multi-core system. It's also important that the microvisor, that actually the hypervisor, manage the power management, the device drivers, and handle the real time of the system. Finally, the health monitoring is very important. So looking at this feature, these features are already implemented in most of the real-time operating system, especially are implemented in integrity of the Greenhill software. So those features are important and can be used to implement a virtualization system using a microkernel. So the microkernel will actually have the possibility to control the system and to separate the critical application from the non-critical, but also to separate the guest from the other application. In this kind of approach, we have the virtual machine monitor running as a native application of the microkernel, of the separation microkernel. The virtual machine monitor is controlling the guest and is guaranteeing also that the guest does not impact, does not interfere the other components in the system. So we have to take into account this kind of virtualization. And this kind of virtualization is actually a mix from a type 1 and type 2. So it's a new kind of virtualization. And this, we will see later, that this will be used to improve the security of our system and so to improve the security of the secure gateway. So let's look at the difference between the Linux, which has the monolithic kernel, separation microkernel, actually, where we have really a microkernel. So the difference between the monolithic kernel is that all the services are running on kernel. So the network stack, the device driver, everything is running in kernel mode. On the other hand, the microkernel just run the basic services in kernel mode, and all other services are running in user mode. So the advantages of the microkernel is that there are few lines of code, and you don't have to test a lot of code, a lot of software, so the probability to have a bug is very low. Also, in the secure gateway, we need to protect sensitive data. And as I mentioned before, having the Linux managing the key is not a good solution because Linux is not secure itself. So that's why we will need security critical application that should be isolated from the rest of the world. And especially the guest should not interfere with the rest of the system. This picture is showing the hypervisor, the microkernel hosted hypervisor architecture. We see that we have Linux, in this case, running as a guest. We see the application of the Linux and the device driver, but Linux does not have direct access to the I/O device. In this case, there is the separation microkernel, and the separation microkernel has a component named virtual machine monitor, which actually is monitoring the Linux guest. As you can see, the security services are managed by the separation microkernel. And this is a very secure way to improve the efficiency of the secure gateway and at the same time, the security. The separation microkernel needs also to use the hardware capability that are available today, like the memory management unit and the I/O memory management unit, which is the second stage memory management unit, where we can protect also the devices, the peripheral. So the access to the peripherals with the IOMMU is protected. We also have on the modern CPUs like ARMv8, we have the exception level, and an hypervisor should really use this exception level to prevent some wrong access to security components. So finally, we have to use these capabilities to really separate the critical application from the non-critical application and to separate the guest. The I/O device security is also really important because an hacker can exploit DMA, for example, dynamic memory accessing, to make an attack to the system. So we have to be careful that the devices are managed by the microkernel. And in this case, we can really provide security, for example, properly configuring the IOMMU and using the virtual drivers that they do sanity check before sending command to the devices or before giving the input to the guest. This is the final architecture that we see, where there is the separation microkernel running in supervisor mode. Then we see that there are critical real-time applications, secure and safety critical application running in user, but still in user mode for the microkernel, which means those are native microkernel application. we see the virtual machine monitor and the virtual driver. On guest supervisor mode, it's running the kernel. So the kernel of the guest does not have direct access to the device or to the security feature. So we need to implement the services that can interface with security feature implemented in the as native application of the kernel. Finally, there are also the guest application, which is also really important. To conclude, in this talk, we saw two different approaches: designing the secure gateway using a separation microkernel, which provide already a real separation between the mixed criticality component. And we also saw how to improve security of the system where Linux is already running on. So on the secure gateway where Linux is already running on. So separation in this case is really important. So managing the separation and using in a proper way the hardware capability is really important. So the separation technology open up new scenario in the automotive world to improve the security of the world system.